Morning, everyone. Afternoon, evening. We're just going to give a couple of more minutes to see if there's any late joiners. Good looking, Dave. Yeah. We'll just give one more minute for any last minute joiners, and then we'll get started. There's people filtering in, Dave, you need to admit. Yeah, it seems there's still some people joining, so we'll just give maybe another minute. Just do a sound check. Is the chat function working? Can anyone put in chat just to check that you can hear us okay? Lucas?
Yeah. More people to no.
No one's confirming. Is the chat function working? Can anyone confirm the sound's working okay? Yeah, thanks, Ronald. Just check Lucas as well.
Yeah, can everyone hear me?
Perfect. All right, thank you. It's still filtering in. I think we'll start at 35 minutes past because it seems people are still filtering in. So just bear with us and thank you for your patience. Chandan, I think that might be an issue on your end. We've got some confirmed sound checks, so just check the settings on your side. Got a few more to admit, Dave. Just give one more minute. They're still filtering in. Okay, it's 35 minutes past now, so we'll get started. Dave, if you can just keep an eye on anyone else who's coming in. So good morning, good afternoon, good evening, depending on where you are in the world, and welcome to our webinar. My name's Daniel Remde. I'm the Marine Sales Manager here at Martek, and I'm joined by Lucas.
My name's Lucas. I'm the Sales Executive here at Martek.
And we've got Dave in the background as well. So if you hear us referring to Dave or asking for the next slide, he's running the show in the background. Thank you all for joining. We've had a really good registration rate, and I think they're going to keep filtering in. So it's great to see lots of our existing customers and others interested in the webinar. So our objectives today are to look at the proposed IMO regulation changes. I'm going to run through that. And then Lucas is going to run through the China MSA inspection campaign. We're going to have a look at the role of cross-sensitivity and put a bit of detail into that. So The webinar will provide practical knowledge and solutions. Martek are committed to maritime safety. An enclosed space entry presents high risks, asphyxiation, poisoning, explosions, entrapment, and it needs careful management. So first, we will have a look at the IMO updates. Apologies, we're still on first slide, Dave, but we'll go on to the next one now. Apologies. So SOLAS is the foundation of maritime safety. It's a convention of IMO, and it stands for Safety of Lives at Sea. It sets the minimum standards for ships, and that's from construction to the equipment on board and the daily operation. A couple of key chapters that we're going to look at. So chapter 3 covers life-saving appliances and arrangements. So that can be anything from lifeboats, pyrotechnics to evacuation. And it focuses on emergency training and drills. And then we've got chapter IX-1, which are special measures to enhance maritime safety, and specifically resolution 7, which is focusing on atmosphere testing instruments. SOLAS is supported by more detailed documents, so resolutions and circulars, and also supported by national rules. So if we go on to the next slide, Dave. Great. So we've got a couple of resolutions and circulars here. These provide more specific details on implementing SOLAS requirements. So the first resolution here is A1050-27. So that's the revised recommendations for entering enclosed spaces aboard ships. Now, this was adopted in 2011. Recently, at the end of last year, September, the subcommittee CCC, or Carriers, Cargoes and Containers, submitted proposed changes. Now, these proposed changes have not yet been implemented, and the date's still to be confirmed. It was set to potentially be approved in spring, but I think the IMO convention will be in June, where these could get approved. Now, as with any new legislation, there's always a grace period. So any changes, there'll be time given to implement them into your operations and your safety management systems. As an example, when these were released in 2011, it wasn't enforced until 2016. And then if we have a look at the circular here, circular 1477, gives guidelines to facilitate the selection of the portable atmosphere testing instruments. We call them gas detectors, for enclosed spaces. And that dictates how many you need, what gases they have to detect, the sort of capabilities, how to maintain them. And these documents are really tools for understanding and applying SOLAS correctly so that you stay compliant. So let's have a look at some of the proposed changes to the SOLAS regulations. Sorry, next slide, please, Dave. So one of the proposed changes is to have a strengthened guidance for emergency response plans. And it's saying that emergency response plans should have detailed procedures for various emergency scenarios, rescue, first aid, evacuations. The plan should have clear roles assigned to each crew member. Everyone should know what is expected of them in an emergency. Plans should have specific instructions for the use of rescue equipment. The crew need training on use of the equipment, and there should be clear communication methods. So how to communicate, what to communicate, and when to communicate. And there also needs to be a mandatory requirement for regular and realistic drills. Basically, everyone must know what they're doing in an emergency. They need to know their specific roles. Next slide, please, Dave. And there's new guidance as well for handling enclosed space entries during simultaneous operations, so SIMOPS for short. And that's whenever there's multiple operations or tasks occurring at the same time in or around a enclosed space. That could be cargo operations, it could be tank cleaning, hot works, electric work, it could be maintenance that's going on. And obviously, when you've got more than one task going on, the risks are increased. There could be conflicting procedure between the different operations. There could be communication breakdowns if people don't know the different operations that are happening. And you're also introducing hazards from one operation to the next. An example of that might be hot works giving off sparks. So there needs to be detailed planning and risk assessment, which covers both operations running at the same time. There needs to be a strict permit to work system. It's no good just turning up and doing the job. That doesn't allow for coordination. There needs to be time planned for each job so that the risk assessments can take into account the different operations. There needs to be clear communication protocols and everyone's got assigned responsibilities. And obviously continuous monitoring of the enclosed space. The key here is that proactive management is the key to safety. Next slide, please, Dave. Right, so another introduction is prohibiting single person entry into a confined space. Quite simply, if something goes wrong within a confined space, a lone worker is not going to be able to rescue themselves. Assistance is going to be delayed. Enclosed space atmospheres can become dangerous very quickly and incapacitate someone. And the risk to a single entrant or a lone worker is unacceptably high. Immediate assistance is vital in enclosed space emergencies. So if we go on to the next slide, we'll go into a bit more detail. So what are the implications of not allowing single person entry? What's going to change? So at the very least, 2 personnel are going to be required for every entry. So there's going to be an entrant, someone who goes in and performs the work inside, and an attendant that remains outside to monitor and assist. And that's just not just monitoring the atmosphere, but keeping an eye on the situation, making sure everything's safe, looking out for any risks. And each of the members will have clearly defined roles and responsibilities. The entrance responsibility is going to be to do the work safely and keep an eye out for any added risks. And the attendant's responsibility is going to be to monitor, again, both the atmosphere and the situation, communicate, raise alarms if needed, and in an emergency, initiate a rescue. And there needs to be continuous and reliable communication. It needs to be agreed what methods of communication are going to be used, the frequency of communication, which should be constant, ongoing, and emergency communication, should it be needed. How are they going to sign for help? It does have some implications on manning. So there is potential need for additional crew members or careful scheduling to allow for the 2 people rather than a single entrant. And it's essential to train all crew members in both the entrant role and the attendant role. So everyone on board needs to be knowing what they need to do in both roles. Procedurally, there could be a couple of changes. So there might need to be a revision to entry permits. There'll be an emphasis on pre-entry briefing, communication before, during, and after the operation, the fact, and reinforced monitoring procedures, which we're going to cover a bit on next. So that's monitoring the atmosphere. So there's a new emphasis on steady readings. So what are steady readings? So that's taking a stable and consistent atmospheric measurement and taking it over time to get a reliable reading, not just doing a quick check and going, oh, yeah, the environment's fine, let's go inside, but it's making sure that that reading is steady over time and there's no fluctuations. You're probably all aware of what we're checking for. There's oxygen. They are stating now in the proposals that it will be 20.9% steady or you're not entering. The low explosive limit will be below 1% LEL, or you're not entering. And the toxic gases, vapors, the common ones obviously being carbon monoxide and hydrogen sulfide, need to be at least half of the occupational exposure limit. Now, the OEL does vary dependent on flag state, and so that needs to be checked. It's different for different flag vessels. It's important to have a steady reading so that you've got an accurate assessment of atmospheric conditions within the confined space before entering. You're detecting potential fluctuations or trends. Steady readings confirm that the atmosphere is safe at the time. It is still important to continuously monitor. We'll look at next some of the potential challenges of getting a steady reading. Next slide, please, Dave. So gas mixes fairly easily. If we take the outside environment, for example, the air is constantly moving, and wherever you take a reading, you're going to get an even and consistent concentration of gas. If you move that example into, say, an office space like we're in now, there is movement of the air, so from the air conditioning, open windows. So there will be an even and consistent concentration of gas wherever you check. But if the ventilation's not sufficient, if the air is not being replaced constantly enough, commonly in an office environment, the CO2 levels will build during the day. But again, it'll be consistent throughout the space. If you then move into a confined space where there's potentially no movement, there's no ventilation, the gas will over time stratify. So that's when the heavier gases come down to the bottom, the lighter gases come up to the top. And because there's no ventilation, the air is not being exchanged, them toxic gases will build up over time. Now, this is going to lead to pockets and layers of potentially dangerous gases, most commonly CO2 settling at the bottom, which can displace oxygen. So it's important when going into a confined space to understand this, not just do a check when you go in at sort of shoulder height. You need to be checking the top of the room, the bottom of the room. If you're entering a confined space and then planning on going down a ladder, for example, you need to be lowering a sample line down. You need to be checking where you're going to be going, because potentially down that ladder, there could be a pocket of carbon dioxide. If we introduce more complex gas mixtures as well, it can further complicate the measurements. So cargo-specific gases which are being released, coal releasing methane, oxygen depleting cargo, so wood, grain, and even rust within the confined space could reduce the oxygen. And if we have a look at cross-sensitivity of sensors, this can lead to inaccurate readings as well, but we will cover that a little bit later on. But I think the vital thing to understand here is that understanding the confined space that you're entering, it's of the utmost importance to understand how the gases work and the confined space that you're potentially going into. So that's it on some of the IMO changes. I'm going to hand over to Lucas now, and he's going to cover the China MSA inspection campaign that's been running this year.
Now speaking on the new China MSA campaign, this has been running from January 15th of this year and will end on October the 14th. So anyone with vessels that are currently trading in China may already be aware of this. The purpose of the campaign is to ensure compliance with all SOLAS regulations and reduce the amount of accidents that occur during enclosed space entrance. The campaign will focus mainly on crew awareness, procedures, all gas detection equipment, crew awareness, and documentation. Inspections across the board are very detailed and cover many aspects of the new IMO regulations, and compliance of this is mandatory for all vessels that are trading in China. Next slide, please, Dave. Prioritising the crew is a huge focus of this campaign, and each member of the crew needs to understand the risks of enclosed space entrance. They need to recognise the symptoms of hazardous atmospheres, make sure permits are in place, and make sure that checklists are being used before enclosed space entrance. All these need to be done correctly by all crew members that are participating in the enclosed space entrance. All gas detection equipment on board must be maintained and calibrated. All of the maintenance and calibration must be recorded and documented on board in order to keep crew safety at an all-time high. Not only this, but the crew need to be familiar with all PPE equipment and all rescue equipment in the event of an emergency plan. Once again, following these procedures is vital when sailing in Chinese waters, and all equipment must be functional and calibrated as per the manufacturer's guidelines. Next slide, please, Dave. As mentioned, the inspections in China are very thorough. They will be making sure that all details are being written down, from procedures to the gas detection calibration, permits, making sure that drills are in place and making sure that the drills are being performed correctly. Not only this, but vessel structure is also something to take into account. The equipment on board, when it comes to ventilation, doors, ladders, they must be sealed, safe, ventilation must be working correctly, and all crew must be familiar with the risks and procedures that take place during enclosed space entrance once again. They must know how to use all gas detection equipment on board. They must, like as mentioned, make sure drills are being performed correctly to ensure crew safety. Keeping a record of all this, once again, is vital for proof of compliance. Next slide, please, Dave. Now, the key takeaways for this: vessels that are sailing in Chinese waters must be proactive. They must use the MSA checklist that you can find online for self-inspection upon arrival in port. This will just ensure that there's no port delays. It will ensure that your vessel's not being detained and not bringing any financial penalties. The main goal of the campaign is to ensure crew safety and to show how serious IMO rules are being enforced globally. As mentioned, being prepared not only avoids penalties, but it protects the crew, which is the main thing. You don't want any potential dangers that can be lurking around to come and surprise you. Next slide, please, Dave. So I'm going to pass over to Dan for the cross-sensitivity side of this.
Yeah, thanks, Lucas. Yeah, the MSA China campaign, it's just making sure that everyone's doing what they should be doing. Procedures and checklists are essential, but they cannot cover every scenario. So we spoke and discovered earlier that enclosed atmospheres are complex and they change unexpectedly, and understanding the dangers within is vital, understanding the potential dangers within an enclosed space. But it's just as important to understand the capabilities and limitations of your gas detection equipment. So cross-sensitivity, when understood, can offer an additional layer of safety. Next slide, please, Dave. So what is cross-sensitivity? It's when a sensor responds to a gas other than what it's targeted for. So an example here we've got is carbon monoxide sensor. So a carbon monoxide sensor typically will respond to acetylene, hydrogen, as well as other solvents and gases. And that's because of the similar chemical properties that these gases, that the gases react to within the sensor's element. Now, there can be a benefit to this. It can provide early warning for other gases that aren't specifically targeted, or the gas detector wouldn't otherwise be capable of detecting. And therefore, it can enhance safety in closed spacing, but understanding the cross-sensitivity is crucial. You need to be able to make an accurate interpretation of the readings, and that's a combination of understanding what gases might be present and the capabilities of the equipment itself. Now, it's important to note that whenever it comes to cross-sensitivity, every gas detector and every sensor is different, so you always need to check cross-sensitivity with the sensors manufacturer. and have solid data on the specific sensor that you're using. But it can provide benefits if used correctly. We've done a white paper on the cross sensitivity of the subject of cross sensitivity. It takes an in-depth look into understanding and its implications. It covers principles, some examples, strategies to manage the risks, and best practice for interpreting the readings. We encourage you to download it, enhance your knowledge. It's a valuable resource. It's free. Take advantage of it. We'll give you a link at the end of the webinar, so we'll give you all the details that you need to download it. I'm going to hand back to Lucas now. He's going to talk about our own personal gas detector, the CCC.
So many of you already know about the CCC. It's a zero calibration, zero maintenance unit with a battery life of 3 years. Now, this will help especially within the China MSA campaign and these new regulations. So as Dan mentioned, the new regulations stipulate that you must have stable readings. Now, the CCC will give stable and accurate readings over a period of time. Not only this, but the MSA campaign also stipulates that equipment must be maintained and calibrated as per manufacturer's guidelines. Now, the CCC, as mentioned, is a zero calibration, zero maintenance unit, and this has been MED, MER approved. This will allow you to easily comply with all SOLAS regulations and will easily allow you to comply with all the MSA inspection campaigns in China. Not only this, but the CO sensor has been confirmed and documented for cross sensitivity. This is with both acetylene and hydrogen. The simple user face on the unit allows for all crew just to easily, easily use it for your enclosed space entry, easily draw the sample from the enclosed space, and there's not a particularly large amount of training that needs doing when it comes to the use of CCC. Next slide, please, Dave. Now, as I mentioned, the CCC and the IMO readings stipulate that steady readings are required, and the CCC is a tool that will help you precisely measure O2, CO, LEL, and H2S within the enclosed space entrance. Reliable data can be transferred from the CCC and be documented using the IR link that we can supply. And as I mentioned, cross sensitivity is something that has been confirmed with the CO sensor. As I move back to the China campaign, and the MSA compliance stipulates that a reliable testing device is required. CCC is that. Its robust design makes sure that damage remains at an all-time low. Calibration for MSA's requirements, as I mentioned, is as per manufacturer's guidelines, which we recommend that it's a zero calibration unit. Crew competency, so the CCC is a very easy unit to use. Its intuitive operation and apparent display makes things very, very simple when it comes to gas detection. And as I mentioned before, data logging is within this unit and can be extracted from the CCC using the IR link. Next slide, please, Dave.
That's it. So we'll open up for questions now. There should be somewhere up at the top a Q&A feature. So if you have any questions, put them in there. We can also, if you want to raise your hand, Dave will unmute you and we can take questions live as well. So feel free to either use the Q&A feature at the top or raise your hand if you want to ask a question. We've got one in chat here. Do you have an overview of the OEL per flag? In essence, no, there's many flag states out there, but if you want to get in touch, Ronald, we can look specifically for your own flag state and find that information out for you. Any more questions? We'll leave it for another minute. Was expecting loads of questions today, but it's quiet. There should be a Q&A button at the top of your screen. It's one in Q&A, Dave saying, regarding the Triple C, does the O2 sensor also last 36 months, and does the device come with a wheel map? Yep. So the O2 sensor is designed for 36 months, and the unit is guaranteed to last 36 months. And it does have the MED wheel mark. To in chat, I'm being told. So I've just noticed the sun's come on me, and I've gone very dark. Do you need special familiarization form for this device? Are you referring, Giovanni, to the Triple C? We have online training available. We're happy to do virtual meetings as well to explain. But as Lucas mentioned earlier, it's a very simple gas detector to use. Ronald's asking if the Triple C LEL reading is defaulted to CH4, and yes, that's correct. It's calibrated to methane. Marcus, no calibration on the Triple C. What is the drift of the sensor over time? Marcus, it's got an infrared LEL sensor, so it's not prone to drift, and any minute drift would be able to be zeroed without the need for calibration. And it's very simple to bump test. You don't need any extra equipment, so there's no bump station. That you can get a bump station, but it's not required. All you need is a canister of gas and a fixed flow regulator. Each unit comes with a clip that forces the gas over the sensors and goes on the front of the gas detector. And we do recommend bump testing regularly, preferably before use, as with every gas detector. Just check Q&A. No more in there. Any more? I think that's it. Okay, we'll move on.
Oh, there's one more question.
Hang on. What can we expect the results that come out of the campaign in China? For me, I think it's sort of this is everything that they're checking for should be being done either way. So it's just putting the pressure on and making sure that people are doing what they're supposed to be doing. And because of that pressure, I think it's going to reignite a sort of safety consciousness, and I think people will, it will move forward into, past the 9-month campaign. I think people will continue with that safety consciousness. So I think it's a great thing. It's just checking that people are doing what they're supposed to be doing, and that making sure that the crew on board these vessels are safe, and that everything's documented in case there was an incident on board. Then investigations can be done to see what the actual cause was, where the breakdown in the safety management system was. But yeah, I think it's a good thing, and I think the pressure that it's putting on to vessels and ship owners who are sailing in Chinese waters, I think that will continue and have an effect into the future. So I think it'll be positive results, and it will increase the safety of our cruise sailing worldwide into the future. Do we have any more? We'll do a last chance saloon. No more in the Q&A.
No more in the chat.
No one typing. Okay. Right. So we're gonna just do key takeaways, what you need to take away from the webinar, and then we'll thank you for attending and say our goodbyes.
So the key takeaways from this and your action plan that you need to have moving forward. Enforcing enclosed space entry regulations to reduce incidents, making sure that plans are in place, making sure that all gas detection equipment is calibrated and maintained before use, making sure that all crew are aware of the risks of enclosed space entrance and they do recognise those hazardous atmospheres. The crew need to make sure that they have control of all entry procedures, making sure everything is done as per planned, and just make sure that everything is documented from the calibration to the drills to the enclosed space entrance itself, making sure the ship structure is at an all-time high, making sure that doors are sealed, ladders are safe to use, lights are safe to use, and just making sure that the crew are competent with all gas detection equipment. When it comes to cross-sensitivity, making sure that the crew are aware that it is a thing, and making sure that the crew are aware that CO sensors can actually respond to acetylene and hydrogen as well. Similar chemical properties allow these gases to react to certain elements in enclosed spaces. They need to provide an early warning of acetylene and hydrogen presence as well. And an importance and understanding of cross-sensitivity, it can be a positive thing. It can be very useful if properly understood. And just the benefits of CCC, it allows you to easily comply with this MSA campaign with its no maintenance unit. It's a very compact, lightweight unit that has an external pump that will allow for enclosed space entrance. It's durable and robust for these harsh conditions. The long battery life would mean that you don't have to worry about charging the unit. You don't have to go to the perform an enclosed space entrance and realize that your gas detector actually has no charge. And it's just a simple unit to use. Crew are going to be very competent with it. As mentioned, the advanced CO sensor does allow for that cross sensitivity with acetylene and hydrogen. But like I said, it can be a positive thing if properly understood.
Yeah, and for myself, the takeaways from IMO, not yet implemented. Potentially, we'll get more news in June. There will be a grace period for any changes to be implemented. So don't stress over that. We'll be reaching out and we'll be giving an update. But understanding confined spaces, how gas works, potential dangers within the gas, within the confined space from cargo, etc. Understanding the equipment, its limitations and its capabilities are utmost important. Combine understanding the confined space and understanding the equipment gives you a really good stead when it comes to entering confined spaces. Great, and that's it from us. Thank you all for attending. Please do reach out on the info@martek-marine.com. Give us a ring at our offices or visit our website for more information. We'd be more than happy to discuss anything that we've gone through today in more detail.
Thank you.
Cheers. Bye.
See you later, everyone.